Alright, welcome back to another video, and today we are going to go into some chemistry and some ions and ionic bonding. So first thing, this is the periodic table. The periodic table is basically just an assortment of atoms and elements, and they're grouped on things based like their electrons, their protons, and their neutrons. That's just some basic knowledge. You should know what it is now, but I'll go over electrons because that's the most important thing for now. Electrons are basically given by this number, the atomic number in balanced atoms, because the electrons is the same amount as the protons, and valence electrons are the amount in the outer shell for the atom. So the way you can see that is by the group. So 1 has 1 valence electron, group 2 has 2 valence electrons. Skip the D block for now because a lot of them are a little bit strange. Group 13 has 3, group 14 has 4, and so on until you get to group 18, which has 8, or in the case of helium 2. We'll get into that in a second. So bonding. Ions are basically positively or negatively charged atoms, and we'll get into how these charges work in a second, but they bond based on their valence electrons, and all atoms want to have a full outer shell of valence electrons. So that coveted 8, or in this case 2, valence electrons is what they want. So the noble gases are that end row that I was talking about. All of these have 8 valence electrons, so they're not very reactive with other elements, and they're very stable compared to something like in the middle, right? They're very stable, and most atoms, pretty much all atoms, want to be like these. And ions are basically formed on the relativity to noble gases. So like I just said, all atoms want to basically be these noble gases. So relative to the noble gases is how ions and charges are formed. And here's an example. So lithium, right? It has 3 electrons, as you can see by the atomic number right here. Atomic number is the number of protons, and in a balanced atom, the number of protons is the same as the amount of electrons. So lithium has 3, and the closest noble gas to it is 2, which is helium. So to have 2 electrons, if lithium has 3, it would need to lose 1. But since electrons are negatively charged, if you lose an electron, you're actually going to go up 1 in charge. And so the lithium ion is basically going to be Li1 or Li1 plus. Or sorry, Li plus. And another example is fluorine. So fluorine is actually on the other side of the spectrum, and it needs to gain an electron to become like neon, which is the closest thing to it. And fluorine gains an electron, but since it gained an electron, which is a negatively charged subatomic particle, it actually goes down 1 in charge. And so it's written as F1 minus or just F minus. It's usually F minus, hence why I circled F minus here and also Li plus here, because it's usually just plus and minus if it's just 1. And so in these examples, we've gotten the ions Li plus and F minus. And one more thing is a minus ion is an anion, and a plus ion is a cation. So I'm going to be referring to it like that from now. And these two ions can ionically bond because they basically need the opposite thing of each other. And so Li plus has 1 too many electrons, and F minus has 1 too little. And one more thing, bonding doesn't need to be 1 to 1. So say lithium needed 2 electrons, and fluorine needed to have 1 less electron. They could still bond, but it would just be a little different, and I'll get into that in the next video, but not today. So you can see that this lithium cation and this fluoride anion combine into lithium fluoride, and so these ions bond. And so that's basically how it works. Every atom wants to become like the noble gases, so the ions form, and then ions can form ionic bonds. So some of the other common ions that bond are magnesium and sulfur. So magnesium has a 2 plus charge and sulfur has a 2 minus charge, and they combine to make magnesium sulfide. And one extra thing is that if whatever the anion is, you replace, for example, this is sulfur, you replace the ending with "ide" instead. So like right here, sodium chloride, NaCl, Na plus, and Cl minus, make NaCl, and Cl normally is chlorine, but it's chloride in this case because it's minus. That's just a general rule. So yeah, sodium chloride is something else. That's just table salt. You probably have definitely seen that before. So yeah, chemistry is actually in your real life as well. And that's all we're really going to get into today. Thank you guys for watching. Next time we're going to be getting into some more complex atomic bonding and maybe some polyatomic bonding.